Okay. So today I'm going to be talking about how basalt is formed and metamorphizes.
Double check that this is. Can you see the video? Yes, it's fine. So go ahead, Molly.
Oh.
That's the video. You're good. Go ahead, Molly.
Okay. Wait. Oh. Okay. So basically, the first step is how basalt is formed. So to make basalt, you need a specific lava, which is it's like a mafic lava. It's the most common type of lava. What happens is the mantle is melted into the lava, and the mafic lava is composed mainly of iron and magnesium, and it's low in silica. This makes a lot of the rocks that are like, igneous, like igneous, like intrusive, like obsidian, or I don't know, stuff like that. Next, okay, yeah. Next, what happens is the eruption. It happens underwater for this specific type of rock, which is called basalt, and it's called pillow basalt more specifically. That's because it happens underwater, and basically, once it erupts, it quickly forms a shell, like a crust shell, over the lava that has erupted. So it forms these pillow-like things that are very porous, and if they're cooled, and they look like this. This is basalt. It has a lot of holes in it, kind of lightweight, stuff like that. And what can happen after it turns into basalt is it can turn into greenstone. Yeah. So greenstone is a metamorphic rock, and basically what happens to greenstone is the pressure. So metamorphic rock is it's like pressure and or temperature, or either or, and maybe both. And it rearranges the particles and changes some in chemical composition. This one is metamorphized with hot percolating seawater, and that's what helps the metamorphosis. And the mineral that gives it its green color is either chlorite, hornblende, or epidotite, and it's formed during the early stages of metamorphism. And what could happen after that is serpentine is created, which serpentine is a rock that goes through retrograde metamorphism, so it is metamorphized after greenstone is metamorphized. What happens is hot water is forced through tiny fractures, which melts the silica, and it creates the silica-rich water. Then it reacts to the rocks like olive iron and produces serpentine-like minerals. And so it also reacts to this water, which turns into, it's converted into hydroxyl groups, and it becomes part of the rock. So those become part of the rock. And the water helps hydrate the serpentine, which gives it its very soapy and, soapy texture. It's very interesting. And here it is. Yeah, it's not as soapy in this, but you can see the greenness from the reaction. And some people have theorized that some serpentine gets to the surface by becoming denser and floating to the surface of the water because it has less density. And so once it is floated to the surface of the water, it turns into clay because of weathering, and weathering causes it to erode into little particles, which causes clay. And there are actually certain plants that can live on serpentine clay. Some plants depend on it. So serpentine is very necessary to the environment. It really shows how It all ties together, all the roots is necessary. So yeah. Yeah, there's my sources. Okay, and then, what? Oh yeah, does anyone have any questions? Or? Okay, I don't think anyone has questions. So.
Thank you, Molly. Thank you. Second clap. Yes.